Assalamu alaikum. Myself, Dr. Ansari Farzana, Veduzzama, Department of Chemistry, J.A.T. Arts, Science and Commerce College, Malegaon. Welcome, all of you. Now, today we will continue conductometry. In previous section, we have seen various topics about conductometry. Today, we shall discuss about calculation of equivalent conductance, conductivity or conductance water, etc. Calculation of equivalent conductance. To calculate the equivalent conductance of a given solution, it is necessary to calculate a specific conductance or a specific resistance of the solution from its measured resistance. So, the equation R is equal to rho L upon A. To calculate a specific resistance from R, it is necessary to know the ratio small l upon small a. For a particular cell, the ratio of distance of separation of the electrode and their cross-section area is always fixed, and it is called as cell constant. Therefore, cell constant is equal to L upon A. After every measurement of R, direct determination of L and A will spoil the electrode. The electrolytic deposition of platinum may flake off during this or may break. To determine the cell constant, indirectly resistance of non-specific resistance is measured. Therefore, L upon A is equal to cell constant is equal to R upon rho. For determination of cell constant, aqueous solution of potassium chloride of non-specific resistance and having a fixed concentration is used. The resistance of KCl solution is determined and cell constant is known by the relation cell constant is equal to resistance of KCl solution divided by the specific resistance of KCl solution. This cell constant has unit per centimeter. A specific resistance of KCl solution is tabulated here. Once the cell constant is known by measuring the resistance of solution of electrolyte of known strength, its specific resistance is calculated as specific resistance is equal to observed resistance divided by cell constant. Reciprocal of rho gives specific conductance from Ls lambda. The equivalent conductance of the solution is calculated by using the equation lambda is equal to 1000 Ls upon C. Conductivity or conductance water. The solution used in conductance measurement are prepared in conductance water. A satisfactory conductance water is obtained by distilling once again a good distilled water containing a small quantity of potassium permanganate from hard glass retort. The specific conductance of this water is 0.8 into 10 raised to minus 6 per ohm per centimeter at 18 degrees C. The conductance in water arises mainly due to dissolved carbon dioxide, which forms carbonic acid and which dissociate to a small extent, giving H plus and HCO3 minus ion. In more accurate work, ultra pure water with a specific conductance of 0.05 into 10 raised to minus 6 per ohm per centimeter at 18 degrees C is used. Ultra pure water is obtained by expelling completely from conductance water the dissolved air. Variation of specific and equivalent conductance with concentration. The dependence of specific conductance and equivalent conductance on concentration of the solution is discussed as depending upon dependence of specific conductance on concentration. The specific conductance depends on the number of ion per unit volume of the solution. The equivalent conductance, on the other hand, depends upon specific conductance and solution concentration. When the concentration of solution is increased, the number of ion per unit volume increases. The specific conductance of the solution therefore increases. The rate of increase of specific conductance with concentration differ in case of strong and weak electrolyte. A strong electrolyte is completely dissociate. The number of ion per unit volume increases proportionally with solution concentration. A weak electrolyte is partially dissociate. Due to its incomplete dissociation, the specific conductance has a low value. Increase in specific conductance with increase in concentration in this case is marginal. Equivalent conductance invariably increases with the decrease in concentration, that means with dilution. On the dilution, number of ion per unit volume decreases and hence specific conductance of solution decreases. But this decrease is more compensated by the increase in factor 1 upon C in equation for lambda. The nature of graph lambda versus dilution plot is shown in this figure. Dependence of equivalent concentration on dilution. As the graph shows, lambda increases with V increases, that means dilution increases and approaches to limiting value in extremely dilute solution. The equivalent conductance of aqueous solution of different electrolyte having different concentration are tabulated in the table. These are the equivalent conductance of different electrolyte at 25 degrees C in per ohm centimeter square. Thank you for watching.